All right, everybody. Today we're going to be taking notes on isosceles and equilateral triangles. So have your notes in front of you here, and we're going to just kind of go through all the definitions and some problems. Firstly, we have the definition for an isosceles triangle here. An isosceles triangle is a triangle with at least two congruent sides. Remember, what the word congruent means is that they are the same length. The two sides will be the same length, and we have a symbol for congruent that looks like this. If a triangle has two congruent sides, it turns out they also have two angles that are congruent to each other as well. The two sides of a triangle, if two sides of a triangle are congruent, then the angles opposite them are also congruent. The two angles that are opposite the congruent sides are called the base angles. So if we take a look down here, we kind of have the anatomy of an isosceles triangle, all the different parts and what they're called. So this triangle is isosceles because you'll see here that we have these markings that say that this side here is congruent to this side. The sides that are congruent to each other are called the legs. So if we name the points or the vertices of the triangle here, we'll just call this triangle A, B, C. The two legs would be side AB and side BC. And these markings are saying that they are congruent to each other. So they would be the legs of this isosceles triangle. Now the angles that are opposite the legs would be angle A. Angle A is opposite side BC, and opposite means across from down here. So angle A would be one of the base angles, and then angle C is opposite or across from side AB. Angle C would be the other base angle. Remember, the base angles are the two congruent angles in an isosceles triangle. So we would say angle A is congruent to angle C. They're also called base angles because the side that's not congruent to the other two is called the base. The side that's not congruent to the other two sides in the triangle is called the base of the triangle. And then the angle that's not congruent to the other two angles is called the vertex angle. The vertex angle is where the two legs come together, and that's where the vertex angle is formed. It's also not the same measure as the other two angles in a normal, typical isosceles triangle here. All right. So if we open up our notes to the next part, we have another theorem that's called the converse of the base angles theorem. And basically, that means that we know that the angles of the triangle are congruent to each other instead. If two angles of a triangle are congruent, then the sides opposite them are going to be congruent. Essentially, you can tell if you have an isosceles triangle if they tell you you have two congruent angles or two congruent sides. Either way, then you'll know that the triangle is isosceles. The way that this is worded, we would need to know that we have two congruent angles, say angle A and angle C are congruent to each other. So if angle A is congruent to angle C, those would be two congruent angles in the triangle. The sides that are opposite them, the side that's opposite angle A would be side BC, and the side that's opposite angle C would be side AB. Those two sides would be congruent to each other as well. So if we have two angles at the bottom that are congruent to each other, those would be our base angles. Then the triangle is isosceles, and we have two congruent sides as well. Okay, so you might remember I said that the triangle has to have at least two congruent sides in order to be considered isosceles. A triangle only has three sides, so if all three sides are congruent to each other, it would still be isosceles, but it will be even more special because all three sides are the same. So that's called an equilateral triangle. So all the properties are true for isosceles triangles that we'll learn for equilateral triangles as well. But everything is going to be equal when we have an equilateral triangle. All three sides are going to be congruent to each other or the same length. Okay. And if all three sides are congruent, then all three angles are going to be congruent as well. All three angles will be congruent also, which means that each angle of the equilateral triangle we know how many degrees it is, or we can figure it out. So something we just learned is that all the angles added together in a triangle all the time is 180 degrees. So if we know all three are the same, we would just divide 180 by 3, and we get 60 degrees for each angle. And if a triangle has all angles congruent, that means we can call it equiangular instead, then it is equilateral. So this is a converse statement like the other one. So if you know that you have all three angles the same, if that's what's given to you, then you can then conclude that all three sides are going to be the same length as well. Okay, so let's go ahead and do some problems and see what we are given and set some things up. So this first problem, we're being asked to solve for x, which means we need to find out what x equals in the problem here. Take a look at the triangle. We notice that we have these two markings here. That means these two angles are the same measurement. They're congruent to each other. Since we have two congruent angles, that means we have an isosceles triangle. And the sides that are opposite those angles, so the 17 and the 3x minus 7, are going to be congruent to each other. So the 17 length here, both sides essentially have to be 17 units here. So 3x minus 7, this side also has to be 17 because this side is 17. So we set up an equation. We have to solve here for x. The first thing that we'll do is add 7 to both sides to get rid of the 7, leaving with 3x equals 24. Divide both sides by 3 to get x by itself, and we would get x equals 8. Okay. Let's take a look. We're being asked to find the value of x in each one of these triangles here, and each one of these examples here. Let's see if this will focus for us. That would be nice, so you guys can actually see and not know that you need glasses or anything. Oh, there we go. Okay, so again, we have two congruent angles, which means this is isosceles, which means the two legs of the triangle here opposite those angles have to be the same length as well. So x and the 7 have to be the same measure. So x will equal 7. All right, in this next one here, we have two sides that are the same. So we have an isosceles triangle. We also have these angles that are the same as well, which basically means that we have an isosceles triangle that's cut in half. The vertex angle up here is being cut in half. So these two sides down here will actually end up being the same measure as well. We didn't really talk about that too much in our other theorems, but that is actually true. So if you thought that that was the case, you would be correct. So x just equals 6 right here. All right, let's look at the next row. What we are given, you should see these little markings. Again, that means that this side and this side are the same. That means that this angle down here and this angle down here have to be the same as well. And one of those is what x is equal to. So we know the vertex angle is equal to 40 degrees. We know all three angles of the triangle add up to 180 degrees. So if we start with 180 and subtract the 40, you'll end up with 140 degrees. This 140 degrees has to be divided equally amongst the two base angles. So if we divide this by 2, each of these angles then would be 70 degrees down here. So x in this problem would be 70. In the next problem, the way that the triangle is facing is a little bit tricky. The sides that are congruent to each other are these two sides. So this side and this side right here are our legs. The angles that are opposite those legs would be the 54 and this angle over here. The x is actually the vertex angle. It's not the base angle. So this angle is 54. This angle is 54 up here. What is the measure of x is the question. What is the measure of the vertex angle? So if we find out what 54 plus 54 or 54 times 2 is, which is 108 degrees, we can find out what the vertex angle is by subtracting 108 from 180. And x will equal 72. So this is an important one. You want to be real careful there because of the way that the triangle is facing. It's very tempting to think that x is a base angle, but the sides that are marked congruent are actually this side and this side here. All right, in our next row, let's take a look. We got a couple triangles. Ooh, we're going to have to use some of our old knowledge, which is awesome. So let's take a look here. We have two legs of an isosceles triangle with the 65-degree angle up here at the top. Okay. These two legs are congruent to each other. That means this angle over here and this angle over here are our base angles, even though they're at the top, which means this angle is also 65. So what is this angle right here? Well, 65 plus 65 is 130. Take that away from 180, that leaves us with 50 degrees. So this angle in the top triangle is 50 degrees. Why are we doing this? That's not where x is. X is in the bottom part of the triangle. Okay? X is in the bottom part of the triangle down here. Well, this triangle is also isosceles, but these two are the sides are the legs, making this angle right here and this angle right here your base angles of the bottom triangle. How many degrees are in each of these angles? So we have to remember our good old friend right here. What do we have? We have an x, two intersecting lines. We have vertical angles. Yay! Don't we miss them? We haven't seen them for a while. And you might remember vertical angles are the same measure. They're congruent to each other. So if this angle is 50 degrees up here, guess what? This angle down here also needs to be 50 degrees. And since this is one of the base angles of the triangle down here at the bottom, that means this other angle is going to be 50 degrees. So how many degrees is x? In this triangle down here, all three add up to 180 degrees. So far we have 50 plus 50, which is 100. So we would subtract 100 and we get 80 degrees for x, or the angle that's marked x. That is a fun problem. so if we picked up where we left off here, we have this next one, which is there's a lot of stuff going on this example here. So if we take a look, we have a lot of congruent segments, which means we have some isosceles triangles happening. Those two angles are going to be congruent because these two sides are congruent. Another set of congruent sides, which means that this angle and this angle are going to be congruent to each other, and x is way over here. If we take a look at this angle and the x, what we're trying to find, these two angles form a linear pair. Another good old friend from the past. Angles that form a linear pair add up to 180 degrees. So essentially, if we know what this one is, we'll be able to subtract it from 180 to find x. Okay, so let's go back over to here where we have some information. This is a line as well, or a ray, and we know that this angle right here is 148. So we should be able to find out what this little angle is right here by subtracting 148 from 180. When you subtract 148 from 180, we get 32 degrees. So this little angle is 32 degrees. And I kind of colored over it, but we have a little box in the corner here, which means that this whole entire angle here is 90 degrees. So to find this part, these two angles are adjacent to each other, add up to 90. We find this part of that 90 degree angle. We would subtract 32 from 90 degrees, which should give us 58 degrees here. So we have a 58 degree angle right here. Since these, again, is an isosceles triangle, we have a 58 degree angle up here as well. Those two angles are the same, which finally now we're up here by x where we want to find. We know these two angles add up to 180. So if we do 180 minus 58 degrees, that's going to give us what? 122 degree angle for x. So that was a good problem. It brought up a lot of old stuff from first quarter and things that we haven't really talked about too much recently, with some angle pairs and stuff like that, just like our good old buddy vertical angles over here. Okay, which looks like we're going to have to use again down here. In our almost last example, we have another x. So let's take a look at the markings. Again, we have an isosceles triangle because these two sides are marked the same. And we have a different isosceles triangle up here, which is where angle 2 is and what we have for our information. We kind of got to know what angle 2 is equal to. So starting down here where we know, this is an isosceles triangle. One of the base angles is 47, so the other base angle here will also be 47 degrees. Okay. Notice again, just like the problem above here, we have vertical angles. Vertical angles are congruent, so this angle in the top triangle is also going to be 47. Angle 2, however, is not the other base angle. Look at the sides markings on the isosceles triangle. These are the two legs. The base angles would be here and over here. This is going to be the other base angle, which is 47 degrees here. So how many degrees are there in angle 2? All three angles add up to 180. So we would add what is 47 plus 47, gives you 94 degrees for both of those, and then subtract that away from 180, and we are going to get 86 degrees. So we have 86 degrees is the measure of angle 2. We have an expression, x plus 94, for the measure of angle 2. So x plus 94 is equal to 86. Subtract 94. When you subtract 94 from both sides, that gives us a negative number, which is fine. We're going to have negative 8. -8. And that's okay because the angle is not negative. The angle measure is +86. The measure or the value for x is -8, and that's okay. Okay, you guys, now we're on our last problem here. Let's take a look again at what we know. We have some isosceles triangles here and here. This isosceles triangle would have these two as base angles, so these two angles would be the same. Another isosceles triangle over here, so these two angles would be the same. This would be the base angles for the orange triangle, essentially. We had a 90-degree angle here that I kind of scribbled over. So the blue and the orange angle would add up to 90. And then we have a set of vertical angles this direction. 118 on the outside here. This is our line. We have vertical angles, and then these two angles would form a linear pair again. 118 subtracted from 180 gives us 62 degrees. So the blue angle inside here is going to be 62 degrees. So is this blue angle, that's the other base angle for this top isosceles triangle. In the corner down here, we had a right angle, so we're going to do 90 minus 62 to find this orange angle. 90 minus 62 gives us 28 degrees. So this is a 28-degree angle. Okay. So we can use our isosceles triangles theorems here. We also could actually just use our exterior angle theorem as well that we just learned about. Angle 2 is a remote exterior angle, so it should equal whatever 62 plus 62 is equal to. But if we forget that and just focus on our isosceles triangles, we know that this base angle is 28, so is this. Okay. All three angles add up to 180. So 28 plus 28 gives you your 56 degrees. Subtract 56 from 180. 124. So angle 2, the measure of angle 2 is 124 degrees. Which sure enough is what 62 plus 62 is equal to. So we didn't even need to do all of the stuff with the 90-degree angle. We could have found angles 2 if we used our remote interior angle theorem, which is kind of a shortcut. Finally, to solve for x, we have an expression for the measure of angle 2, 12x plus 4. So 12x plus 4 is equal to 124. Solving for x, we would subtract 4 first. 12x equals 120. Divide by 12, and we get x is equal to 10. So that should be it for our examples and everything about isosceles and equilateral triangles. Pay attention to the markings, know which sides are congruent to each other, and therefore which angles would be considered the base angles and congruent to each other as well.